Hello my dear students, in this lecture we are going to see Stokes theorem. In previous lecture we have seen the physical significance of curl. And my dear students, the physical significance of curl is nothing but Stokes theorem. That statement you understand. The physical significance of curl that we have seen in previous lecture is nothing but Stokes theorem. But as in university exams, they are asking separately question on curl and what is the physical significance of curl as well as on Stokes theorem. That's why we are learning here separately. And in statement format and in another point of view, we have to learn this Stokes theorem. So let us start with Stokes theorem. Now my dear students, again before physical significance of curl, we have seen the Gauss theorem. And Gauss theorem gives the relation between the volume integral and surface integral. You can remind the things, right? Or you can go back and check. The Gauss theorem gives the relation between volume integral and surface integral. And here Stokes theorem gives the relation between surface integral with line integral. So here I have written this Stokes theorem relates an integral over an open surface, means it is a surface integral. Relates an integral over a open surface, means it is a open surface integral. The surface is open. This is important, right? Here always surface is open. Closed surface is not acceptable, or closed surface is not accepted, right? Here surface must be open. Don't worry, I will tell you what is the exactly closed and open surface, right? Gives the relation between, relates the integral over open surface to the line integral around the curve bounding the surface, right? To the line integral around the curve bounding the surface, means it is a closed line integral or cyclic integral, right? For a closed surface, right? Now but here surface is open, my dear students, surface is open, but the surface is bounded by the closed lines. Let us understand the theorem. Stokes theorem states that the circulation, now in previous lecture we have seen circulation. Circulation is nothing but cyclic integral of any vector field dot dl, where dl is position vector, means it is a line integral over a closed envelope, right? It is a line integral over a closed curve, right? This is called circulation. In previous lecture we have seen this. Stokes theorem states that the circulation, that is line integral around the closed path of a vector field A around the path L. Now here closed path is called path L. So here I will write instead of C, here closed path is said as L, right? Around the closed path L is equal to surface integral of curl A. Now curl also we have seen, del cross A is nothing but curl, right? Then what they are saying is equal to the surface integral of curl A, vector A, over open surface S, bounded by the closed path L, provided vector A and the curl of vector A are continuous on surface S, right? Now let us understand mathematically what they are trying to tell here. See, the circulation is nothing but cyclic integral over a closed path vector A dot dl is nothing but circulation is equal to, now they are saying that the surface integral of curl, therefore open surface, it is not closed surface, therefore here there will be no circle, like this there will be no circle, open surface, surface integral of curl, that is del cross A dot ds. Ds is area vector, where ds is area vector. Let us understand diagrammatically. But the surface must be open, and the path must be closed, right? Let us understand diagrammatically. Let us consider any random path. Let us say I have path like this. You can consider any random path, right? And my dear students, here this is a surface, right? Here this will, you will find surface, and this path they are saying as a closed path, which is as L. Let us say my circulation is around anti-clockwise direction. I am assuming anti-clockwise circulation, like this, anti-clockwise circulation, right? Like this. Now my dear students, here this closed path is called L, right? It is a line integral, and this surface, right? Now my dear students, so you understood that what is the line, it is a closed path, and surface, it is an open surface. Now the same surface you will find from back side, the same surface you will find from the back side, which is again open, right? Now on this surface, now on this closed path, if I consider very small element, see how I am considering small element, very small element I am considering like this, and this is very small, infinitely small, right? And let us say the length of this element is dl, very very small length, means you will find that this length is a straight line, though it is a curve, but you will consider the element such that the very small part of this curve, so that you will feel that it is a straight line only, right? Therefore it will be a straight line, therefore it is a dl, this vector is dl vector, right? And my dear students, again on this surface I will consider very small area. Let us consider very small area on the surface. If I consider area like this, see this is very small area, again this you will feel that it is straight area, flat area, this is not curvy area, this is a flat area, you will feel that, right? And my dear students, let us say this area is ds, right? Now direction of dl, we know that in the direction of rotation we have to draw here tangent at the surface, tangent. Likewise, see if I consider surface over here like this, tangent, this is the direction of dl. Now direction of dl we can find, right? But direction of ds will be, see we have seen that the direction of ds is calculated by screw rule or right hand thumb rule, right? Right hand thumb rule or screw rule, means here right hand thumb rule I cannot explain on the this class. Physical class is required to explain this right hand thumb rule, because the hand movement and thumb movement you have to show in right hand thumb rule, but screw rule easily you can understand. See, you have water bottle, now try to open the water bottle. To open the water bottle you have to rotate the closing of water bottle in anti-clockwise direction. Therefore my dear students, if this surface is rotating in anti-clockwise direction, if I am rotating in anti-clockwise direction, this will come outward, and for clockwise direction it will go downward. Similarly for the pen, if you want to remove your refill from the pen, you have to rotate in anti-clockwise direction so that it will come out, and if you rotate clockwise it will go down. Similarly screw, if you want to fit a screw in your wall, if you rotate the screw in anti-clockwise direction it will come out. If you rotate the screw in clockwise direction in your wall, it will go inside the wall, right? Therefore see, it is anti-clockwise rotation, therefore perpendicular to this area, perpendicular to this ds, outside. For anti-clockwise direction it is outside like this, and it is perpendicular to ds, that you have to assume. In 2D view we have to assume, right? This is a perpendicular 90-degree angle. And for clockwise rotation, see this is for anti-clockwise rotation of line. For clockwise rotation this ds will go here, direction will go like this, ds for clockwise rotation, means for clockwise rotation it will go inside, for anti-clockwise rotation it will come outside, right? That you have to consider. Let us say the surface is like this, let's say the surface is like this, let's say this is x-axis, this is z-axis, and if this axis is rotating anti-clockwise, for anti-clockwise direction the direction of this area vector will be upward we can say, and for this is for anti-clockwise rotation, and for clockwise rotation the direction will be downward, ds for clockwise rotation. Or you can understand for clockwise inside, for anti-clockwise outside. Likewise you can understand this direction. I hope you understood. And this is a ds vector or area vector. Del cross A is curl, which is also vector quantity. Vector dot vector is a scalar, dot product is always scalar, and we know that how to write this scalar. Here vector dot vector is scalar, that is a dot dl is written as a dl cos theta, right? This is how it is written. And a is a any vector field, any random vector field. And my dear students, the here Stokes theorem is applicable only for the open surfaces, it is not valid for the closed surfaces. So what we have seen, for closed path line, and the path is L, the closed path is L, the line integral a dot dl is nothing but, for open surface the surface integral of curl, surface integral of curl. This del cross A is a curl and dot ds is a surface integral, right? But surface is open surface. Now for closed surface, what happens? Let us assume football. Football is a closed surface. See, like this spherical surface, right? This is a football. It is a closed surface. Now my dear students, let us say if I consider here a very small element, then the surface here, the area vector will be perpendicular to this surface, right? And exactly opposite, there will be a exactly similar element. If I check exactly opposite, there will be a exactly similar element here, and for this also the area vector will be perpendicular to this surface. And here these area vectors are in line of equal magnitude, therefore they will cancel each other. Similarly, if I consider any other location, let us say at this location, if I consider this surface, right, perpendicular to this surface, there will be a area vector, and exactly opposite to this surface, there is exactly similar surface perpendicular to this, there will be an area vector. So here we can say this area vector will cancel this area vector, this area vector will cancel this area vector, and the net here vector quantity ds will be 0, net ds will be 0 on this surface. So my dear students, here we can say the for closed surface, it is a closed surface now, it is now closed surface symbol. For closed surface, this del cross A dot ds becomes equal to 0, right? That's why this theorem, Stokes theorem, is not applicable for closed surface. It is valid only for the open surface. This is very much important. This is very important. And also my dear students, it cannot be applied for the surface like Mobius strip. It cannot be applied for surface like Mobius strip. Now my dear students, here Mobius strip is nothing but it is having only single surface. Mobius strip is having single surface. It is do not have two surfaces, and for such type of surface integral is the Stokes theorem is not valid, right? So Stokes theorem is valid only for the open surface and closed path. Now here let us say here it is a surface PQRS is a surface, and the path is closed path, that is path PQ, QR, RS and ESP. This is a closed path and surface is open surface. Now my dear students, let us understand the proof of Stokes theorem. Now let us consider proof of Stokes theorem is nothing but physical significance of curl is nothing but Stokes theorem. Here I will write physical significance of curl is nothing but Stokes theorem. Is Stokes theorem. Stokes theorem. Now let us understand what is the physical significance of curl. Already we have defined the curl is nothing but del cross A is nothing but curl, and curl is nothing but line integral per unit area. It is line integral per unit area. This already we have defined, right, in previous lectures. That is line integral over a closed path. It is A dot dl divided by area, right? This is called curl. Now my dear students, let us consider any open surface randomly. I consider any open surface. Let us say this is my open surface. Now for this open surface, it is having closed path L. This is a closed path. Let us say this is a closed path. I am assuming path in anti-clockwise direction like this. This is L, and here this is an open surface. Yes, open surface. Yes. Now what I will do, I will divide this surface into n number of small surfaces. What I will say, divide total surface into n number of small surface. Divide surface into n number of small surface. Now let us divide. So what I will do, I will divide like this. See, this is how I am dividing this into very small surfaces, very small surfaces like this, right? So my dear students, here let us say I have divided into 1, 2, 3, 4, 5, 6 and such n surfaces, total n surfaces. Now randomly I will consider any one surface here. Randomly, let us say this ith surface I will consider. This ith surface I am considering here. Now for this ith surface, if I take this surface outside, this surface will look like this, right? And let us say, my dear students, here for this surface, the length is dl. Here this total length is dl perimeter. This complete perimeter is dl, right? Which is nothing but length path l, right? Let us say its path is li. Here this path is, I am assuming, li, right? And this surface is very small, that is dsi, del si, or we can say del si, right? Now my dear students, for this very small surface, how can we write the physical significance of curl, right? That is, curl is nothing but, here we can write the curl del cross a for very small surface we are writing is nothing but line integral per unit area. Therefore it is line integral over li, which will become line integral of vector a dl, right? Line integral, it is a for the surface, right, divided by closed surface divided by area. Now what is the area? Del si, del si, this will be the area, right? So my dear students, let us take this area on this left side. Therefore curl del cross a into del si will be equal to line integral over a surface li, here we can say over a length li for this closed path li, vector a dot dl, right? Now what I am doing here, I have divided this surface into n number of surfaces. Now what happens if this n becomes equal to infinite? What if this n becomes infinite? Then I will get very small surfaces, infinite surfaces. I will get very small infinite surfaces, right? So my dear students, in this case, for very small surface, the area will be 0, approximately equal to 0, and then this del s will become ds, right? Del s will become ds now, right? So my dear students, and if I integrate over entire surface, then I will get total surface, integration of surface, integration of curl over surface, right? So let us do this. Then I will get integration, right? Integration del cross a dot ds, right? It is over surface, open surface, is equal to, now my dear students, for here this become, that is li. Now this li for first surface, second surface, third, fourth, fifth, sixth, such like infinite surfaces. Therefore this will become integration of closed surface over path l, that is complete path l into a dot dl, which is nothing but Stokes theorem. This is the Stokes theorem. Now let us understand this, how we can write like this. See, this term writing is very important. This term leads into this term. Why or how? Let us understand. Now my dear students, for infinitely large elements, this term becomes summation of all. Here integration means summation of all, na? Therefore how we have to write? Integration over L1 a dot dl plus integration over L2 a dot dl plus integration over L3 a dot dl plus so on for infinite times, right? So my dear students, here for infinite times we are doing. Now what I will do, I will consider any three elements. In between I will consider any three elements, and for three elements I will observe what will happen. Let us say these three elements I will consider what happens, whether it is leading to over complete enclosed path el or not, right? Let us understand. So here I will erase this diagram so that I can consider only three elements, and same result we will project for entire area or entire length, right? Now my dear students, here let us say these are the three elements. Here I have considered three elements and I am enlarging them, right? Let us say this is the first, second and third element. For first element, if I do surface integral, if I do here line integral, see, if I consider anti-clockwise path, let us say this is the path for the first element, right? Therefore my dear students, See, while doing line integral for the first element, that is line integral of L1 path, this is a L1 path, A dot dl will be equal to, see how we are doing dot product, it is line integral of A dl cos theta, right? Now let us understand, this is for first, four paths are there. Now second, let us observe second, the same sense, we are assuming same anticlockwise sense, I am drawing with red color, let us say this is L2, same anticlockwise sense, right? Now observe here, now can you clearly state that the intermediate paths here, this intermediate paths for first surface, the line integral for this intermediate path is upward, and for second surface it is downward. Means this upward will cancel this downward, because my dear students, here theta is, for one case theta is 0 degree, upward is 0 degree and downward is 180 degree, right? For one case theta is 0 degree and for other case it is 180 degree, right? Means cos 0 is 1, cos 1 it is -1. Means this upward is cancelled by this downward, means I can delete this internal boundary, boundary, right? Similarly, draw for third, same sense we have to keep here, third surface L3, same sense, anti-clockwise direction, right? Now my dear students, again look at the internal element, again this upward will cancel downward, means internal paths directly we can delete, now what path I will remain, or I will get, only external path I will get, and the same is L, external path is L, means internal paths, these dot products will cancel each other, that's why only external path is remaining in the same sense, that is anti-clockwise direction. That's why the same integration Li A dot dl summation for infinite time I can write like this, right? I hope you are understanding this, and this is the proof of Stokes theorem, and Stokes theorem is very much important. So my dear students, try to remember the Stokes theorem like Gauss theorem. So here I will tell you what is the Gauss theorem as well as Stokes theorem. So my dear students, in previous lectures we have seen Stokes theorem as well as just now we have seen Stokes theorem, and in previous lecture we have seen Gauss divergence theorem. Gauss divergence theorem gives relation between surface integral and volume integral, and in Gauss divergence theorem it says that the surface integral or area integral over a closed surface, here symbol is shown, over a closed surface here for any vector field A is equal to, now it is a surface integral over a closed surface for vector field A is equal to the, here it is a divergence del dot A, is divergence, therefore it is equal to the volume integral, dV is volume integral of a divergence of A over volume enclosed by S, right? Therefore here surface integral of closed surface for a vector field A is equal to the volume integral of divergence of A, right? But what is Stokes theorem? Stokes theorem gives the relation between line integral and area or surface integral. Now for a closed path, the line integral of a vector field A is equal to, for open surface it is a surface integral of curl of vector A. Here there is a divergence, here there is a curl, and here there is a closed surface, here there is a closed path. Here in Stokes theorem it is open surface, in Gauss theorem it is a closed surface, right? In Gauss theorem there is a divergence, and in Stokes theorem there is a curl. I hope you understood this. Thank you dear students. In next lecture we will see the curl of electric field.